Algebra 2, target 33. I can perform and evaluate a simulation model. Now, a simulation model is kind of like an observational study or an experiment, except it's cheaper because you don't have to go out and buy stuff, and it's quicker because you don't have to wait for stuff to happen. All right? The steps for for a simulation. What's the question we are trying to answer? We want to make sure we know that. What is the data we are trying to simulate? What numbers can we use to represent the situation? And what guidelines will run the simulation best? So let's look at a couple simulations, run through them, and look at our results. Our first simulation. Late in a basketball game, the team that is behind often fouls someone in an attempt to get the ball back. Usually, the opposing player will get to shoot foul shots 1-and-1, meaning he gets a shot and then a second shot only if he makes the first one. Suppose the opposing player has made 72% of his foul shots this season. Estimate the number of points he will score in a 1-and-1 situation. All right, so what is the question we're trying to answer? We're trying to answer the average number of points the player will score. What is the average number of points the player will score? All right. What is the data we're trying to simulate? We're trying to simulate a player shooting 72% from the line. And we're going to do that by simulating random numbers. The random numbers we're going to use, since it's a percent, it's always a good idea. You can always use 100. So we're going to randomly generate integers from 1 through 100. 1 through 72 are going to represent a make. And 73 through 100 are going to represent a miss. And we're going to generate our first number. If it's between 1 and 72, we're going to generate a second number. If it is not between 1 and 72, we're done with that trial. All right, so I'm going to get out my calculator. And I'm going to go to my random number generator. Lowest number is 1. Highest number is 100. You could generate 2 right away if you wanted. I'm going to, and just ignore the second number if it's not in the proper range. All right, so the first time to the line, he gets 77 and 39. So the first time, he misses the first one, so he doesn't get that second one. So the first time, or the first simulation, he will score 0 points. So you're going to make a table. The first time, he gets 0 points. All right, now we're going to run the simulation again. Just hit enter one more time. We got 2 and 36. The 2 on the first one is a make, so he makes the first one. The 36 on the second one is also a make, so he scored 2 points on this trip. So on this trip, he scored 2 points. And we're going to run this simulation 100 times. And when we run the simulation 100 times, we see that he has scored 2 points 51 times, 1 point 21 times, and 0 points 28 times. So, what is the average number of points? Well, he went to the line 100 times, and on those 100 trips, the first 51 of those times he scored 2 points, so that's 102 points. 21 times he scored 21 points. And 28 times he scored 0. So altogether, he scored 123 points. 123 points on 100 trips is 1.23 points per trip. So we can expect to score 1.23 points. Our next problem. 4 couples at a dinner party play a board game after the meal. They decide to play as teams of 2 and to select the teams randomly. All 8 players write their names on slips of paper. The slips are thoroughly mixed, then drawn 2 at a time. How likely is it that every person will be teamed with someone other than the person he or she came to the party with? All right? So the question we need to answer here is how often are all the teams different than who they came with? And what we want to do here, we want to simulate 8 numbers. And we want to simulate them in pairs. All right? So we want to simulate them so that 1 and 2 came together, 3 and 4 came together, 5 and 6 came together, 7 and 8 came together. So we want to see who the teams are. We would like to generate this one without repeats. So what I'm going to do, some calculators have it, some calculators don't. I happen to have one that does. We want a random number generator with no repeats. If you don't have one, you just keep going. If a repeat comes, you ignore it. Kind of cross it off. We go 1 through 8. N is we want to take 8 numbers to see where they're pairing up. And what I'm looking for is I'm looking to see how many people are paired with the person they came with. So my first trial, here are the results for the first trial, and I want to take a look. Did anyone come with who they came? Is anyone paired with who they came with? So here's the teams. Pair them up. And we can see that 3 and 4 came together and they were randomly paired together. So this is once where the teams were not different. Right, so there's once where they were not different. All right, so then let's run it again. Get 8 more sets of teams. We'll take a look. And this time, here's the teams. 5-1, 6-4, 8-2, 3-7. And here, all the teams are different. All right. We'll do another simulation here, or another trial. Another set of teams. We've got the teams 7-3, 5-2, 8-4, and 6-1. And again, all the teams are different. All right, and we'll run this simulation 100 times. And when we run this simulation 100 times, we can see that 65 out of 100 times, everyone has a unique partner. And 35% of the time, or 35 out of 100, some people are paired with who they came with. So in review, the steps you need to follow when doing the simulations. You need to figure out what question you're trying to answer. And then you need to look at the data and see what you're trying to simulate. Take the data and see which numbers represent the situation best. If you're doing a percent, you can simulate from 1 through 100 and assign a range to each value in your simulation. And then what guidelines best run the situation? In the 3 free throws, we're simulating 2 numbers at a time. And we're tallying how many points they got. In the couples at a party, we were grouping them in sets of 2 and seeing if they were any sets of 2 that matched the original sets that came to the party.